Dear students, welcome to Dr. B.R. Ambedkar Open University video lessons on programming with C and C++ for UG third semester students of computer applications. Today we are going to discuss about pointers and strings. Myself, A. Lakshmi Bhargav. Before going to start about pointers, first we will learn about computer memory. So the data stored as bits and bytes. As we know, whatever the data we are storing in computer uh, will be stored in the form of bits and bytes. I think we know about bits and bytes. So coming to bits, bit is nothing but either 0 or 1. 0 or 1. Byte is nothing but 1 byte equal to 8 bits. 1 byte equal to 8 bits. Variables occupy memory locations. Every location has unique address, and addresses are generally in hexadecimal format. So if you take one example here, int a equal to 10. Here a is nothing but a variable, and 10 is the value stored in the variable a. Coming to int is a data type here, already we know. So when we declare a variable and assign some value to the variable, it will be stored in the computer memory. So if you take here, value 10 will be stored in the variable a, and the address of a will be like in the hexadecimal format like 0x1000. Any variable, any value that must be stored in the memory will have some unique address. Why we need to pointers here? See here, pointers are help to access the memory directly, and efficient memory management, pass arguments by reference, dynamic memory allocation, arrays and strings, and data structures. If you take one live example, for example, a person is there, that person is nothing but variable we are thinking. So to easily locate, just we have to check his address. So here uh, home address is there, person is variable we can say, and his address, home address, we can say it as a pointer. By using pointer we can easily access or identify that particular person. Here the main use with pointers is to easily locate the address of the variable. So coming to here, how to declare a pointer declarations. If you take here, the pointer will be declared with the following syntax. Here the syntax is data type, we need to write which type of variable we are storing. That data type will be right here, and star mark, that we can say in general it as a asterisk. In our programming language we can call it as asterisk. So here the pointer name, any name we can use as a pointer name, as already we know about rules for declaring variables names. So by using those variable names rules, we can declare any pointer name here, and the data type is must and should. If you take the example here, int is our data type. Here asterisk mark will represent the pointer, and p is the pointer name. And here if you take character is data type, asterisk represents the pointer, and c is the character variable name. Coming to say float and double. These are the data types, and asterisk marks denotes the it as a pointer, and this f d this we can say it as a pointer names. Pointer type must match the variable type. What are the fundamentals of pointers here? If you take here one example, int x equal to 25. Here x is a variable, 25 is the value stored in the variable. If you observe clearly here, value of x 25 is stored here, and address of that x is 0xAABBCC something hexadecimal address is there, and that will point to the particular value. So when we are writing int star px, I mean int asterisk px, here x is a normal variable and px is a pointer variable, and here this pointer variable is which data type? Integer data type. That means in this px pointer we can store only integer type of variable value, I mean address. So if you see here px equal to ampersand x, here ampersand is nothing but address operator, x is the value. Address of x will be stored in pointer px. That means px stores some address of the variable x something. Whatever the value we are giving here, that address will be stored here. Coming to address operator here, already we have discussed in our previous slide address operator. So address operator is nothing but ampersand. We can call it as a ampersand. So coming to syntax of address operator, here ampersand is address operator followed by variable name. Whatever the variable name we are taking, that we can take here. So if you observe clearly here, this is the syntax ampersand, and whatever the variable name we have to take, that we can take here. Coming to one example, int a equal to 5. This is a normal variable. A is normal variable. And now what we are doing, we are writing one statement printf percentage p. Here percentage p, it denotes the address, and we can write instead of p like percentage u also. It also gives address of the variable. So ampersand a, we have to observe here a value is 5, but coming to ampersand a, ampersand is nothing but address operator. That's why address of a will be printed here. The output will be like 0x some 1 triple 0. Like address may be anything. We cannot say this is a fixed address and this is the actual address. Just we are taking one example for the address that should be in hexadecimal format, and it will be changing based on the time to time. So finally the output of this program will return the address of a. Now next one is the indirection operator. That is nothing but it is also asterisk. So asterisk operator, whatever the asterisk is there, that we can use for pointer declaration as well as indirection operator. That is nothing but dereferencing operator. So dereferencing means whatever the address we are assigning uh, to the pointer. So by using that pointer, we can extract the value, that we can say it as a dereferencing operator. If you take one example here, int a equal to 5. Here a is a variable and 5 is the value stored in a. So a equal to 5. Now what we are doing, int asterisk p. Asterisk is our pointer. Asterisk p is nothing but we have declared one pointer variable here, and directly we are assigning one value, That value is nothing but address of A. Address of A is nothing but it will not store value of A. It will store address of A. When we are declaring and assigning the value like this, one address will be given to A. In that particular address, the value of A will be stored. For example, the address of A is this 0x1000, and that address will be stored in pointer. As we know the definition of pointer, pointer stores address of another variable. So here, coming to definition of the pointer, we can simply say like uh, pointer is a variable and it stores the address of another variable. So here the pointer p stores address of another variable a. That means p will store the address of a, that is nothing but 0x1000. Now, what is the purpose of dereferencing operator? Dereferencing operator means we have to extract or access the value of that particular variable. Whatever the address stored in the pointer p, in that particular address some value will be stored. To access that value, we need to use this dereference operator asterisk. So for both declaring the pointer variable and accessing the value through address, we are using only asterisk operator. So star, I mean asterisk p value will be 5 only. That means actually in p the value will be like address of a. When we are using dereference operator, it will go to that particular address and it will print whatever the value is there in that particular address. That is the purpose of dereferencing operator. Now, if you take one example here, hash include stdio.h. This already we know. This is a header file, and it is nothing but a standard input output. Whatever the scanf, printf statements we are using, those all should be there in this stdio.h. And every program will starts with main, and now we are taking one variable u, and in that the value is like some 3. That means u is a variable in that it will store some value like 3 we have already given, and the address of this u maybe like 1 x 1 some 000 or whatever it may be, like some hexadecimal address. And here just for example I am taking this address only. And now int v, this is also one more variable, and here v is a variable, and here we didn't assign any value here, so it is empty. And here also like it is also one address, like some 1 1 1 1, like that some address it will store. And one more variable is int pu. So now actually int star pu, and it is a pointer variable pu, and it is a again pv. Now if you see, and pu is a one variable, and that is a pointer variable, and this may also have some address, like something is there address, and pv also is there, it may also have some address, like it is also empty variable, didn't assign anything. And here also some value and some address will be given to this pv also. Now what we are doing, pu is assigned with ampersand u. that is nothing but address of u will be stored in pu. Address of address of u is nothing but 1x1000, that is stored in this pu, like 1x1000 will be stored here. And coming to this v, what we are storing, like uh, some pu. Pu is nothing but it assigns the value. So actually what is there in pu? In pu, address of u is there. So it will go to this particular address. In this address, what is the value here? 3. That 3 will be assigned to v. That means the value of v also will be 3 only. Next, what we are doing? PV will be assigned with the ampersand V. That means address of V will be assigned to PV. Here address of V is this one, and this address is like 1x111 is there, and next one we are printing u equal to percentage d ampersand u equal to percentage x pu equal to percentage d. That means what we are printing here, u value is always 3 only. Ampersand u is nothing but address of u. Pu is nothing but it contains the address of u only, and star, I mean asterisk pu, that is value of pu, that is u value, that is nothing but 3 only it will display. Coming to same here, it will print v value, it will print address of v 1x111, and it will print pv is nothing but address of v, that is 1x111 only, and asterisk pv is nothing but whatever the value is there in PV, that address location value like 3 will be printed again here. Now pass by value versus pass by reference. So what is pass by value and what is pass by reference? Pass by value means we are passing a value in the functions. Already we have discussed about functions. Now change is a function and a is a value. Whatever the value of a is there, that we are passing, that is pass by value. Here only one copy of the value will be sent, and here original value will be unchanged, and here there is no pointer concept in pass by value. Coming to pass by reference, so here only address will be sent. Here if you take the example here, change ptr is a function name, and what we are sending here, pass by reference. Reference is nothing but we are sending address as a like parameters. Already we have discussed in functions, we have like parameters. So parameters are arguments. Whatever the values we are sending through function, that we can say as a pass by value, or sorry, arguments are parameters. So here only in the pass by reference we will send only address. If you observe clearly here, change ptr ampersand a is nothing but only we are sending address of a. Already we have discussed ampersand is nothing but address operator. That means only address will be sent as a parameter. So the function, called function, will take that address, and it will move to that particular location, and it will access the value. Next, original will change whenever we are changing the value while passing this as a argument, passing address as an argument. In called function, if you change the value, then at value, original value also will be changed, because here we are sending only address. That means whatever the address location is there, the value will be updated. Now this pass by reference uses pointer. Here we have used already address operator, and to dereference it we have to use pointers. That means asterisk operator we have to use. Already we have discussed about dereferencing and address operators. Now passing pointer to function, here we see here how it will be executed. So here we are taking one function called void change ptr. This is function name, and here int asterisk a. So actually this is a called function for us. That means whatever the calculations, whatever the modifications, and these all things to be done in called function. Coming to call function, here this is the call function change ptr ampersand a. Initially, if you are taking one example, initially if you take a value equal to 10, a value equal to 10, now we are passing, that means ampersand a we are sending, that is nothing but a will be stored, and here the value 10 will be there, and for this variable 1 address will be there, 1 x. Why I am using always x1, this all things means address always will be stored in the hexadecimal format. That's why I am taking it as an example. You can take any address value, that's not a matter. So when we are passing address of a here as a parameter, then this one 1x1000 will be passed to here. That means here it will go like 1x1000, and what we are using here, we are using dereference operator here. That means whatever the address is there, it will move to that particular address, and in that particular address, what is the value here, 10, that will be dereferenced. That means finally it will be treated as a 10 only. Okay, that means asterisk a value is 10. Now what we are doing, asterisk a equal to asterisk a plus 1. Asterisk a value is how much? It is nothing but 10. Already we have dereferenced from here, and this 1 will be added to this one. 10 plus 1, that is nothing but 11. That 11 will be updated in address of, I mean dereferencing of a. That means this is the a, and here the value will be updated like 11. The value will be updated like 11. This is about passing pointer to function. It's nothing is there here. Already we have discussed in functions, like we can pass the arguments, pass by values. But what we are doing here, we are passing some pointers as arguments. When we are passing pointers as arguments, whatever the changes we are doing in that particular variable, that will be reflected in the original place. That means here the value will be reflected. You can see here, before a value is 10, once after executing that function, the a value will be changed to 11, because here by using dereferencing we added 1 to that our variable a. Now you can see here pointers arithmetic. So pointers arithmetic means already we know, like arithmetic means like we can perform some operations, these all things. Here pointer arithmetic means all operations we cannot perform by using pointers. Only some of the operations we can perform here. So what are the allowed operations while using pointers are p plus plus. That is nothing but plus plus is a increment operator, we know. Plus plus is increment operator, we know. For example, p, we are thinking it is as a pointer. P is nothing but here it is a pointer. Star p, I mean asterisk p is nothing but a pointer. So p plus plus increment operator acceptable, minus minus decrement also acceptable here in the pointer arithmetic. P plus 1, we can add one value to the pointer, and p minus 1 we can decrement the value also. Sir, how it will be worked? Like you take some p is a pointer variable, and in this pointer variable what we are going to store? Address of some variable. So for example, address of address stored in pointer p is just for example, for easy understanding, I am taking this as my address as 1000. Actually it will be stored in a hexadecimal format only, but for easily understandable purpose I am taking address as 1000. Now we are taking this pointer variable as a integer variable. Pointer variable as a integer variable. We all know about integer size is 4 bytes. Already we know integer size is 4 bytes, character size is 1 byte. Okay, float size is 4 bytes. So now what we are doing? P plus 1. P plus 1 means what we are doing? Previously, if we are adding plus 1 to the normal variable, then only one value will be incremented. But coming to pointers, p plus 1 means one memory location will be added. That means previous memory location is 1000 means p plus 1 means 1004. P plus 2 means 1008. Like that, p minus 1 means initially if it is 1000, then it will be like 996 will be the address. So that is about pointer arithmetic. Now functions to pointers we can see. Already we discussed about how to pass the pointers to functions. Now it is functions to pointers. Here the syntax for this is we will take integer variable or any any data type, and here function with a pointer. Here if you see this function program, here add is a function, and every program starts its execution from main. Now we have declared like int ptr pointer variable, and this is the function. So it is a function, and how many arguments we are passing? Only two arguments we are passing here, and ptr equal to add. Actually add is nothing but our one of the function. Now it will go to this one. Here two variables are there, a and b, all are, you can say it as a parameters, and what we are saying written a plus b. Now printf, what we are calling ptr of 10 comma 20. 10 comma 20 are the variables, a value 10, b value 20. That 30 will be written by add function, and that function value will be stored in this ptr. Now the output will be 30. And what are the uses with this functions to pointers? Here we can call back the functions, we can sorting the values easily, and for menu driven programs we have to use this concept. And coming to some operating systems and these all things, while executing the programs in a queue, these all things, this will be useful. Now we can see complex pointer declarations. Int asterisk p. This is nothing but p is a pointer to an integer quantity. And now int asterisk p of 10. It is nothing but p of 10 is a array of pointers. P of 10 is array, and it is a pointer. Like p is a 10 element array of pointers. Now you can observe one more thing. Int asterisk p of 10. Here you have to observe the parenthesis. This is p is a pointer to a 10 element integer array. So you have to observe the clear difference between these two. Now it is a void pointer. It returns the pointer to an integer. Here if you are writing void means you can take anything, and if it is an integer means it is integer. Some character asterisk a. P is a function that accepts the pointer to a character and returns an integer. Character asterisk a star p. It's a function that accepts the pointer to character and returns a pointer to an integer. Now P character A of ampersand. It is a function that accepts a pointer to a character array and returns an integer. Now you take hashtag P char star A of array. P is a function that accepts an array of pointers to characters and returns an integer. So this is about pointers. Thank you.